Picture this. While Tesla dominates headlines with their electric vehicles and SpaceX launches capture our imagination, a 275-year-old invention from one of America's founding fathers is quietly revolutionizing the industrial world. Benjamin Franklin didn't just discover electricity with his famous kite experiment. He invented the world's first electric motor in 1748, 70 years before anyone else even came close. But here's the kicker. We buried it, forgot about it, and handed the entire electric motor industry to foreign competitors using inferior technology. Now, as America faces critical shortages of rare earth materials controlled by China and a supply chain crisis that threatens our industrial independence, Franklin's forgotten invention is making a comeback that could reshape everything. The story begins in 1748, when Benjamin Franklin was conducting what he called electrical amusements in his Philadelphia laboratory. Most people know Franklin for his diplomatic work, or maybe that kite and key experiment, but few realize he was essentially America's first tech entrepreneur. His electric wheel, as he called it, was a marvel of engineering that operated on principles so advanced that the materials and manufacturing capabilities of his time couldn't support its practical implementation. Franklin described his creation with characteristic precision, a wooden shaft passing through a thin board about a foot in diameter, with 30 glass strips radiating outward like spokes, each tipped with a brass thimble. When positioned near charged Leyden jars, the 18th century equivalent of batteries, the wheel would spin at 12 to 15 rotations per minute, with enough force to support the weight of 100 Spanish silver dollars. What Franklin had discovered, without even fully understanding it himself, was that electric fields could generate mechanical force more efficiently than the magnetic fields that would later dominate the motor industry. His electrostatic motor operated on fundamentally different principles than the electromagnetic motors we use today. Instead of using copper coils and magnets to create rotation, Franklin's design used the attraction and repulsion between electrically charged surfaces. The science was sound, the execution was brilliant, but the technology of 1748 simply wasn't ready for what Franklin had envisioned. The practical limitations were crushing. Franklin's motor required thousands of volts to operate effectively, creating dangerous sparks and requiring insulation materials that simply didn't exist in the 18th century. The glass and crude metals available couldn't handle the electrical stress, leading to frequent breakdowns and safety hazards. More importantly, the power output was minimal, impressive for a scientific demonstration, but useless for any real industrial application. When Alessandro Volta invented the electrochemical battery in 1799, and Michael Faraday demonstrated electromagnetic rotation in 1821, the world had found a more practical path to electric motors. Franklin's electrostatic principles were abandoned, and electromagnetic motors became the foundation of the Industrial Revolution. Fast forward to today, and that decision to abandon Franklin's approach has created a strategic vulnerability that most Americans don't even realize exists. Every electromagnetic motor in every factory, every electric vehicle, every wind turbine depends on rare earth magnets that are overwhelmingly controlled by China. Beijing controls roughly 90% of global rare earth processing, giving them enormous leverage over American industry. These materials are essential for the permanent magnets that make modern motors work, and China has already demonstrated their willingness to use this control as a geopolitical weapon, restricting exports during trade disputes and forcing American companies to build manufacturing facilities in China just to access these critical materials. The copper situation isn't much better. Traditional electromagnetic motors require massive amounts of copper for their windings, and global copper supplies are increasingly strained as electrification accelerates worldwide. The International Energy Agency projects that copper demand could double by 2040, driven largely by electric vehicle production and renewable energy infrastructure. For a country trying to rebuild its manufacturing base and achieve energy independence, this creates a fundamental problem. How do you build an electric future when foreign competitors control the raw materials you need? This is where Franklin's 275-year-old innovation becomes not just historically interesting, but strategically critical for America's economic future. A company called C-Motive Technologies, spinning out of research at the University of Wisconsin-Madison, has solved the fundamental problems that plagued Franklin's original design. Using modern materials, science, precision manufacturing, and sophisticated control systems, They've created electrostatic motors that operate at efficiencies exceeding 95%, significantly higher than the 84 to 92% typical of electromagnetic motors. More importantly, these motors use 90% less copper than traditional designs and eliminate rare earth magnets entirely. The implications for American industrial competitiveness are staggering. C-Motive's motors can produce 20 to 50 Newton-meters of torque at 0 to 300 RPM without requiring gearboxes, permanent magnets, or active cooling systems. That's 10 times the specific torque of traditional motors, while using materials that can be sourced entirely within the United States. The company has already attracted investment from Rockwell Automation, one of America's largest industrial automation companies, and is conducting real-world tests with FedEx at a distribution center in Texas. But the technical achievements are only part of the story. What makes this truly significant for America is the supply chain independence it enables. While electromagnetic motor manufacturers scramble to secure rare earth supplies from China and cope with volatile copper prices, electrostatic motors can be built using printed circuit board technology, dielectric fluids, and aluminum, materials and manufacturing capabilities that exist throughout the American industrial base. This isn't just about building better motors, it's about building them without depending on strategic competitors for critical materials. The timing couldn't be more crucial. As the Biden administration pushes massive infrastructure investments in electric vehicle charging networks, renewable energy systems, and industrial automation, the choice of motor technology will determine whether that investment strengthens American manufacturing or deepens our dependence on Chinese supply chains. Every motor installed in an American factory or charging station represents a choice between Franklin's domestic approach and the foreign-dependent electromagnetic alternative. The early results from industrial testing are remarkable. In comparative demonstrations, electrostatic motors operating pumps at the same speed and flow rate as electromagnetic motors showed dramatically reduced heat generation and near-silent operation. Thermal imaging revealed that traditional motors operated at only 60 to 65% efficiency, while electrostatic motors maintained much higher efficiency with minimal energy waste. For industrial applications, this translates directly into lower operating costs and reduced maintenance requirements. Perhaps most importantly, these motors excel at the direct drive applications that eliminate gearboxes entirely. Traditional electromagnetic motors struggle to produce high torque at low speeds, requiring complex and expensive gear reduction systems. Electrostatic motors can deliver high torque from 0 RPM, making them ideal for industrial conveyors, automation systems, and electric vehicle applications where direct drive significantly improves efficiency and reduces complexity. The broader implications extend beyond just motor technology. If electrostatic motors can achieve widespread adoption in American industry, they could trigger a renaissance in domestic manufacturing by eliminating one of the key dependencies that has driven production overseas. When you can build high-performance motors using domestic materials and manufacturing capabilities, the economic equation for American production changes fundamentally. But this technological revolution isn't happening in a vacuum. Chinese companies are also aware of electrostatic motor developments and are conducting their own research programs. The question isn't whether this technology will be developed, it's whether American companies will lead its commercialization or whether we'll once again find ourselves dependent on foreign suppliers for critical technology. The race is on, and early leadership could determine industrial competitiveness for decades to come. The story of Franklin's buried invention serves as a powerful reminder that technological progress isn't always linear, and that seemingly obsolete approaches can find new relevance as enabling technologies mature. In Franklin's era, the materials and manufacturing precision needed to make electrostatic motors practical simply didn't exist. Today, advanced dielectric fluids, printed circuit board manufacturing, and sophisticated power electronics have finally caught up with Franklin's vision. What we're witnessing isn't just the revival of an old technology, it's the potential vindication of American innovation and industrial independence. Franklin's electrostatic motor represents more than just a better way to convert electricity into motion. It represents a path toward breaking free from the supply chain vulnerabilities that have compromised American industrial sovereignty. The transformation from Franklin's simple glass and brass wheel to today's sophisticated printed circuit board motors with proprietary dielectric fluids represents more than technological advancement. It represents the vindication of a fundamental scientific insight that was simply waiting for the world to catch up. In our current era of supply chain vulnerabilities and great power competition, Benjamin Franklin's electrostatic motor may finally receive the recognition and implementation it deserved all along. So here's the real question facing America today. Will we seize this opportunity to reclaim industrial leadership in electric motor technology? Or will we watch another American innovation get commercialized by foreign competitors, while we remain dependent on their supply chains? Franklin gave us the blueprint 275 years ago. The materials and manufacturing capabilities exist today. The strategic need is undeniable. The only question is whether we have the will to build the electric future that one of our founding fathers envisioned, centuries before anyone else even dreamed it was possible.